So we have the OSI model, and all we're going to talk about is the layers, the encapsulation concept. So this is a way to understand how computers communicate with each other from one end to the other. So we're going to look at, and we're going to compare and contrast the different devices, features, and placement too. So we're going to kind of talk about the OSI model and how things are in relation to that model. So when we talk about we're using, so for example, I'm using a web browser on my end, and it's going to connect to the other side to a web server. And so the OSI model is going to talk about the communication all the way from me looking at this screen all the way across down to the ones and zeros that are going to travel across the media on the network to the other side. So we're going to kind of go through how all of that works. And it's just a way of giving you a sense of how it works. They have an example here of when I'm looking at my browser, that's me putting a letter in the mailbox. So this is all similar to kind of sending something in the mail. So you have your browser that that'll be your letter that you're sending. The operating system is, we're going to send it through, and it's going to hit the operating system, the hardware, and then it's going to go across the network. So it's going to go through the post office. The post office is going to handle it, take it down the road to the next post office, up to the web server. So I always think about, I had, when I got married, I sent out a ton of invitations, and I went to the post office, dropped them off. They got delivered on the other end. They may or may not have gotten delivered. It's not guaranteed delivery unless you choose certain things. Same with this. It's not guaranteed delivery. And then they made it to the person on the other side. So that's how, kind of how information travels across. And they always use that post office metaphor. It is a pretty good metaphor, but it's just very, very popular metaphor they use. So the OSI model was developed so that we can see kind of how things work. And it was developed by the International Organization for Standardization, or ISO. So we all still use this OSI model to talk about and to kind of think about how things are and how we can troubleshoot those networking protocols and problems. Because when we think about things in different layers, so like, for example, we've got layer 1 is the physical layer and layer 2 is the data link layer. If it's at, sometimes people will say it's a layer 1 issue, meaning it's a physical issue, because a lot of the time things can be physical issues. In our Cisco networking lab, when we're plugging things into switches, we're missing a lot of those little clips, so it doesn't always clip into place. And that's not a big deal unless the cable falls out. So, and then that's a physical layer problem. But the data link layer, physical layer, all of the hardware protocols, all of that, that's one where we can go, oh yeah, we can see those issues. And then we've got the network layer, which is our IP address. So we've got IP addressing there. ICMP, which is ping, and ARP. And again, we're going to go, there's full chapters on all of these. Transport layer, TCP, we've got port numbers at this layer as well. So these are all operating system layers. And then the application layer, that means 7 should be up here too. So we've got session and presentation layer, and so we've got HTTP, HTTPS, SMTP. We talked about these protocols all of these. And so these are all embedded into the OS, and they work with the TCP/IP protocols. And they're the applications that we use to send information. So really, we're gonna get online and we're gonna search for items over the internet, and we're gonna use HTTP or HTTPS. So really, those two correlate. Email, those are the protocols that we're gonna have. FTP or transferring files, those are the protocols we're gonna use. So these are the actual applications, and then these are the correlating protocols. And the Network Plus exam expects you to know this. Cisco networking, the CCNA, that expects you to know it too. So the and I remember this as, here's the P, please do not throw sausage pizza away. But there's also, all people seem to need data processing. And when I took the CCNA, you had to memorize so much. And so I did use that to help me out. When I took that certification exam, there's a survey in the beginning that I rushed through, and then I used their little, I used the rest of, I didn't submit the survey right away. And then I took the time to write everything in my brain down on a piece of paper, because I wasn't answering questions and getting frustrated at that time. So I took everything, I wrote it all down out of my head, and it was onto this dry erase board. And then I was able to use that just in case. I didn't need to, but it was something that helped me through that. The CCNA is a tough certification. So now we'll go through all of the different all the different layers. So the application layer is the one that is closest to the user. It's the one that we'll see and we'll use. So that's the HTTP. We see that. That's an application layer protocol. SNMP, which is Simple Network Management Protocol, that's one that we use for monitoring and looking at network traffic. It can also alert network admins if there's anything going on. Like when I'm in my office and I'm downloading multiple things, it will let them know that I'm downloading too much. So I always I've been at the point where I send an email to my friend Danny, and I'm like, hey, I'm downloading a bunch. Can you? You're probably going to get a notification. So, and then anytime that data is passed between applications or utility programs and the operating system, that's the payload. So it has all sorts of information and includes that control information with it. And then we do two computers communicate. There's not a good graphic here, but two computers communicating with you at the other both ends are called hosts. Presentation layer, it's just responsible for the format. Maybe if you need to encrypt or compress the data, it's going to put it in a format for the receiving end to read in. So like an email, maybe it needs to be encrypted. So the presentation layer will take care of that. Session layer, this is just how applications are synced. And if messages don't arrive intact, it will work with that. So Zoom is one of those, is a good example, and it maintains a session between endpoints for as long as that video is in progress. So these three layers, the top three, so the application, presentation, session, they all work together. So sometimes there's a blurry line in between which one is, which layer does what. And my brain is working faster than my mouth. So they're constantly working together. So sometimes there's just kind of a blurred line in between what each one does. So we want to, there is the individual tasks, but we also just know that they all work together. So most tasks are performed by the OS when an application makes an API to call to the OS. So an API is an application programming interface, and that will call to the OS to request something. So it's going to access information from the operating system. And so from now on, OS, I always use the term OS, and that's just operating system. And we make a lot of requests of the operating system. Transport layer. So now we get into, so the top three are kind of like, how we're going to view things. Now we're getting into transporting across the network. And so we start using some addressing, not IP addressing, but we start using like protocols for port addressing. So we have transport layer is it uses two different protocols. And so one guarantees delivery, one does not. So TCP guarantees delivery, UDP does not guarantee delivery. So like when I was saying that, I sent when I mailed out a whole bunch of invitations, not all of them got there. So it wasn't guaranteed delivery. So it'd be like using the UDP protocol. Does not guarantee delivery. So TCP guarantees delivery. It is therefore considered connection oriented. So what it does is it makes a connection in order to ensure that the data is received at the other side. And then if it's not received, it will resend it. So that is guaranteed delivery and guaranteed that everything will make it to the destination. So it's kind of similar to, I don't know if anybody's done this, but I've had to do this before where I've had to send a package. It was for a grant, and I had to have somebody sign off that they received it. So sometimes that has to happen, and that was guaranteed delivery. It does take longer, and it's used, though, for important information. UDP, connectionless, doesn't care. So this one's broadcasting or streaming video or audio over the web, so it's not as important, but you want fast transmission. So guaranteed delivery is something that kind of goes to the wayside because we want it to be faster. UDP is also network monitoring stuff. So transport layer protocols have what's called a header. And so this is where we start the encapsulation process. And everything is divided into segments. And so what happens is in this area, we'll talk about this in more detail. So its encapsulation starts, we have a header that will have a port number attached. So what that port number will tell you what traffic is being transmitted. So if it's HTTP, if it's HTTPS, if it's Telnet, if it's SSH, so it'll tell you what port you're using and what protocol you're using. Then we'll get to the IP address and the MAC address and the ones and zeros, and those are the jobs of the lower OSI layers, such as this network layer. So the network layer, also known as the internet layer, also known as, so network layer, layer 3, could be called the internet layer. I don't really call it the internet layer. I'm more into network layer or layer 3. So, and that is where we have the IP protocol. So we add the IP address in this one. So then we have the transport layer. I'm going to go back one. I don't mean to ruin your eyes, but so in this one, we encapsulate it. So we encapsulated it into segments. And then we go into the network layer, and it's encapsulated into, it's a packet. So we're going to keep going, and we keep adding headers on there, and this header is going to add the IP address. So we've got IP address information. So the IP address is also known as, so we've got IP address, logical address, layer 3 address. So sometimes those are the multiple names for that as well. And again, this is all information we'll go over later. And so IP is unreliable. It is connectionless. So it relies on other protocols to work with it for finding the best route for other items. So you'll see TCP/IP working together a lot. And so TCP is connection oriented and IP is connectionless. So they work together a lot. And then other supporting protocols are ICMP or ping. So ping is a way to test. Ping is one of the items for ICMP, and it's a way to test your network connectivity. And then there's ARP, which is Address Resolution Protocol, and we'll learn more about that. It's a way to figure out your MAC address to IP mappings, because everybody has to have one of those. So when we start dividing things into packets, we call that fragmentation. And the way they're saying this here is a little bit, I don't know, it's a little bit funky the way they're saying it. So then we go into the data link layer. This is the MAC address layer. So we've got data link layer. Sometimes people just call it the link layer. I don't know. I've always called it the data link layer. Unless I'm losing my mind and I forget to say data. So this is where you're going to have the MAC address. And data link layer protocols are our Ethernet and our Wi-Fi protocols. And again, we're going to go through all of this in detail. And layer 2. So sometimes we got data link layer, layer 2. MAC address is the physical address or the layer 2 address. And so then we're going to keep putting more information on this. So the MAC address information is what we're going to put on this section. And it's also going to put some stuff in what's called that. So we got a header, and then we'll have it in a footer. So data link, it's all encapsulated into a frame. And MAC address is media access control. And see how they say here, media access control address. So MAC address, physical address, hardware address, data link layer address, layer 3 address. So it could be, this one is a hard one because people can say many different things. And so it's got like multiple names. And then finally the physical layer. So this is where we finally get down to the ones and zeros that a computer thinks in. So it's the electrical ons and offs that go across the media, across the network. So it's sending the bits on the wired or wireless transmission. So they're just wavelengths in the air or voltages on your wiring. So the wavelength is your wireless. Voltage on copper wire is your Ethernet twisted pair. And then if you're using fiber, it's light. So those ons and offs are sending the bits, the ones and zeros. It's represented in different ways on the different media, which there's a whole chapter on that. Okay, so here I'm kind of glad. I'm kind of glad that they put this into a table, because now we're talking, we've got the OSI model layers, but then we have kind of the protocol data unit, and they were sort of saying the encapsulation process for that. So we have the encapsulation process where we have our data. So application layer presentation session puts everything, all the data, we have it all nice and neat, ready to go. And then the layer 4 will segment it and set it up in the proper format for TCP versus UDP. And then it will start putting headers on things. And so we've got, it breaks it up into a datagram or a segment. And then layer 3 will put the packet information on there. Layer 2 is we've got frame information. And then layer 1 is our bit or our transmission. So we've got all of the different ones. And the other thing I kind of wanted to, and this might mess everything up, but if you click on a table, oh, this one doesn't do it, but in my 102 class, if you clicked on a table, it would take you to a different page, and it was really annoying. So luckily it doesn't do that here. And then finally, we've got, so here's our final representation. So we have our browser is our application. So we've got the browser is the application presentation session that's all working at the browser level. And then it's going to travel across the network. So we have our payload at layer 5, 6, and 7. So that's why we have the P here. So or data. And then the transport layer is going to put a little header on that payload, and it's going to segment it to make it easier. It's going to break it up, make it easier to go across the network. Then our network, we're going to add a packet on there. So it's going to take this info, add another header so this is going to be our port address. This is going to be our IP address information, both destination and source. And then it'll take that information and it's going to put a header and a trailer on there to just kind of package everything nice and neatly in the end. And we've got the header information is going to include the MAC address, source and destination. Oh yeah, see, this is what it does. And so then now that I have this, it's actually better because it's bigger. So now that I have this here, I'm going to have to hit back to get out of it, just so you know. And then that information will travel across the physical network, go through the switch, and the switch will go to the data link layer to see what the MAC address is, to ensure that it's going to go to the right destination. Then that goes to the router. This is actually a really good picture. I wish Cisco has its own version, but this one's actually really nice. I might use it for my Cisco class. So the router takes off all of the information so it can look at the network information. So it de-encapsulates all the way to the layer 3 info, and it looks at the IP address because a router uses the IP address and the switch uses the MAC address or the data link layer address. So then it looks at that, knows where to send it, and then it sends it on to the web server. And then where the web server goes through the whole process, looks at the payload to be able to respond properly. So I had to hit back. So I had to hit back to get back out of it. I haven't found the best way to do that yet. So when it does, so when the router kind of goes back a couple, that's de-encapsulation. So removing a header or trailer is de-encapsulation. Same here, it has to de-encapsulate to see everything. And again, this is one of the better pictures I've seen of this. And then here's all of this. So the steps through the OSI layers. So here's kind of all of the steps to it. And I'll let you review that on your own. And so that's 1-4, because the next one is 1-5. So I think the next one will be 1-5, and I'm going to see how far I can go if I can include 1-6 and 7.